Today you'll be learning about another type of transformation called a reflection. The word reflection is used in our daily lives, and that's exactly what a reflection in math is. Reflections are everywhere. We see our reflection in a mirror, in glass. In this example here, we have a lake. And we can see that that mountain is reflected into the lake. The picture on the right shows that black line, that shoreline, is what we can call in math the central line. And what's important when we are looking at reflections is that every point from the central line is the same on the opposite side. So for example, this tip of the mountain here would be the same distance away from the center line as this point is here. And any point that we choose on this image would be the same from that center line. And that's going to become important as we move on into dealing with reflections on graphs. So we can reflect over the x-axis and the y-axis. Turn to this page in your notes packets. Make sure that it says x-axis over here so that you are on the right page. We're going to start by reflecting over the x-axis, which is this axis right here. And again, we want to make sure that our distance from each point to that x-axis is the same on the opposite side. So, for example, B, I can see is 2 away from the x-axis, which means on the opposite side of the x-axis, it also needs to be 2 away, making my point right here B prime. And we're going to do that for each point. So again, C is 2 away from the x-axis, which means on the other side of the x-axis, it also needs to be 2 away, making it C prime. And lastly, A is 6 away from the x-axis. So on this side, it also needs to be 6 away. That should have been in red. Let's just change that quickly. And then this is my A prime. So I can connect these lines now. And this blue triangle is my new image. And we can see that this blue triangle I just reflected from the this quadrant into the other quadrant is the same shape and the same size. So again, similar to a translation, this is both congruent and similar. We also want to record our points. So this is going to be now +6, -6, +3, -2, and +9, -2. In a minute, you'll come back and you'll try these two problems and then just try to write the rule. But for right now, I want you to turn to the next page. And we are now going to reflect over the y-axis. So our y-axis is right here. And similar to what we just did with our x-axis, I need to figure out how far away each point is from my y-axis now. So from B to my y-axis is 3, which means on the other side it needs to be 3 away, making my point here B prime. And then for C, I can see that C is 9 away, so that means C has to be 9 away on the other side. So here would be C prime. And then again, A right here is 6 away from the y-axis. So again, it needs to be 6 away from the y-axis on the other side. And here would be A prime. And I can draw my triangle. Again, I can see that these are both similar and congruent because they're the same shape, same size. And then I'm going to make sure I record my points. So we know A prime is now -6, +6. B prime is -3, +2. And C prime is -9, +2. Go back to the other page, so this page right here, and I want you to complete the other two problems for the reflecting over the x-axis, and then same thing for the y-axis. You can pause the video and come back when you're done. So looking at the answers for 2 and 3 here, so again, we're reflecting over that y at the x-axis. We're reflecting over here and making sure every point is the same distance from that x-axis. So here are the points you should have got, and here is your image. And similar for the third one, again, reflecting over that, that x-axis and making sure every point is the same distance to that x-axis as it is on the other side. When we're looking at the rule for reflecting over an x-axis, this is the arrow notation that you might see or a question might ask for. We always, again, start with that x, y, and then the arrow. And as you can see in these problems, if you look at the points, your x is always staying the same. So if we're looking at this one above here, the x was -2, the x stayed -2. X was -9, stayed -9. See, x was -9, stayed -9. What's changing though is your y. So your y is becoming the opposite. So y was -6, y became 6. Y was -4, y became 4. And that's going to happen if you can look back for each of them. So make sure you have this written down in your notes packet as well. If we look at the answers to reflecting over the y-axis, again, now we're reflecting here, this line over the y-axis, that's our central line, making sure the distance on one side is the same as the distance as the other. And same thing here. And if we're looking at the general rule for now reflecting over y-axis, again, you're always starting with that x, y, and the arrow. But now notice that your y is the one that is staying the same. And your x is the one that's becoming the opposite. So x was -2 in this example here, it became 2. X was -9, it became 9. So the general rule or the arrow notation that you would say is that the x's are switching, the y's are staying, and that's how you would write it there.